All right. So, hi, my name's Joel, for those that don't know me. I'm a director at Agoda, and I'm going to talk about some developer experiments that we've done today. So, most of these are just small things that we did, they're little quick wins. When we're looking at MLTC, RTTM, and CTFT in the last couple of quarters, that I just wanted to share, and I got some data as well. So, one of the big things that we found, though, most of the things I'm going to talk about today are mainly about speeding up CI and some local developer stuff. But one of the things that we found when we're experimenting was there's also a big part of your process that impacts MLTC. So I'd recommend looking into that and not only the technical solutions as well. So I'll start with the quick wins that we had on CI. So one of the things that we noticed is there is a few things that you'll be using that may not be doing stuff in parallel. There's a couple of frameworks like NUnit where you've actually got to add variables and things to make it run in parallel in CI. And we got some quick wins with that. So if you're looking into your CI pipeline, have a look if there's things that are running in series. Another thing that we saw, and I saw this was a common mistake that people were making, is if stages in GitLab, the way that they function, if you aren't using DAGs, which I'll get into in a minute, is an entire stage has to finish before the next one will start, unless you use DAG. So what DAG is this little need tags. It's called direct acyclic graphs, but it basically makes your pipeline function like this. And if you've got a needs tag, it will ignore the stages and it'll start running straight away before the previous stage ends. It also helps you, even if you don't have a dependency, you need to add an empty needs tag for it to ignore the previous stage and make it stop waiting. And these help as well because there's some default jobs that are in GitLab out of the box that run in this pre-stage. And if you're not using the needs tag, your initial stages will wait for these and it'll make your builds take a little bit longer. Keeping your versions up to date. So we recently upgraded a ComWeb to Node.js 21 from 14, and they got about a 20-30% increase in their test run time on CI. So make sure whatever frameworks and versions that you're using, you may be able to get some speed increases just by bumping to the latest version. Closing the inner loop. So I want to talk a little bit about what is the inner loop and outer loop development. They link in a lot to the stuff we've been doing with MLTC and CTFT and stuff the last few quarters. What the inner loop of development is, it's the cycle that you go through on your laptop, right? It's I finish my code, I build, I run my test. I finish my code, I build, I run my test. The outer loop starts generally when you push to Git. And it's more about the cycle that you go through beyond just your laptop. It's your code review, it's waiting for CI, it's deploying to production and things like that. So what we've been focusing on is the inner loop. And one of the things that we found was sometimes the inner loop of development, you need to push to CI. And if you need to push to CI to validate a local code change, it's really going to slow you down. I saw this great Twitter post on this the other day. Like literally this is some of my guys, right? They make a change, they push to Git, they wait. They make a change, they push to Git, they wait. So if you're in this scenario, trying to focus on pushing more to the inner loop is really going to help you speed up. And there's some industry research here. I feel smart. I did some, there's a research paper here that I'm quoting. So some of this research is saying from context switching on two things at the same time, you're reducing your efficiency by 20%. And the more and more you context switch, the more impact it has on your efficiency. So I want to try and stop people from context switching and just focus on, I'm going to complete this task and just again and again and again, be able to do that without switching to something else. So one of the things that we looked at was test containers for this. So the test containers, what they do is it's basically it orchestrates Docker containers from your test harness. They're multi-platform, they're available for Java, .NET, Python. And this is what we looked at was the number of, and they essentially replaced Docker Compose for us. And so instead of having to run these command lines and then after running the command lines, running your tests, it's all done from running the tests. And you can see the data that we looked at here was the number of engineers that are pushing to Git, and on the same day, they're running the integration test locally. And we saw over time, after adding test containers, more and more engineers were running locally. And we also saw a correlation with failed pipeline runs. And there's kind of a correlation with MLTC, but it's a bit noisy. So I'd recommend looking at test containers. Test containers are good if you've got a low number of dependencies. If you've got a really high number of dependencies, you probably want to look at what Alex was talking about earlier with DevStack. Speeding up the inner loops. So vitest is another thing that we're looking at. So vitest is an alternate test runner to Jest. If you're using Jest right now, I would definitely look at this. One of the things on the box, though, is it said with vitest that it was going to be 2 times faster than Jest, and we weren't really sure about that. So we decided to try it out to see if we could increase the speed of CI. So the impact that we saw on CI from vitest, it was there. It's like 10–20% tests running faster. But the real impact that I started to notice with my guys, and we did some measurement on this, was vitest by default does a watch. And so if I'm doing a test watch, it's dynamically running the tests in the background as I'm working. And so instead of the 3 to 5 minutes that it'd take for a full test run, it's just snap. It's like hot reload. It's running the test, so those guys aren't waiting. And we noticed an increase of about 20 or 30% of people using watch on vitest over Jest. So we know that they're getting a better local experience. So definitely recommend checking out vitest. So mocking cross-cutting concerns. So we had things in our repo like the experiment manager, the CMS client, things like that. And at startup, these things pre-warm themselves. And that becomes a problem, I think, because one of the things that we look at is the time it takes from when a developer presses debug in their IDE to when they actually get a web page up that they can look at, something like that. And we put some metrics in a few of our repos, and some of the things that we're noticing was in a repo like this one, we've got about a 2 to 3 minute time between when someone presses debug and then the web browser pops up, or when the developer opens the web browser. So that's telling us that they're pressing debug and they're going away and checking their emails and checking Slack or something like that. But then when we had a look on one of our other repos that had a 20-second startup time, that gap is only about 5 to 20 seconds. So the engineers are staying there. They're not context switching. This is what we want to avoid, the context switching. So one of the things that we did is we mocked the experiment manager. You can see here, this is the startup time. It's going down about 10 to 18 seconds, and it's keeping that performance, the startup time of the application on the local low, so the engineers are less likely to context switch and more focused on the work that they're doing and get a better experience overall, because no one likes to wait for things to load. Avoiding laptop setup. So there's a lot of things that you can do to automate. There's a lot of IDE config that you can put in Git that we've started to do. And I've seen a few other teams start to do this over the years as well. Yeah. So, and I've seen heaps of Confluence pages that have things like this, like open IntelliJ, go into edit configuration, copy and paste these settings and go in. And this takes time when developers are ramping up on new systems. So what if I told you you don't need to create these pages? So there's IntelliJ specific settings you can put into Git. So you don't need to have these Confluence pages of do this, do that. There's also .editor config I'd recommend trying out for general IDE settings. .editor config is also cross-IDE compatible. It works, the same settings you put into it will work on VS Code, IntelliJ, all the major IDEs. Don't forget Git attributes as well. If you don't know what Git attributes is, please Google it. It'll help you make your text consistent between Windows and Mac. It also works with ReSharper and VS Code. IntelliJ supports required plugins in Git. So if you've got plugins that people need to install to debug your applications, you can put this into Git. VS Code supports saving recommended plugins in Git. It'll prompt you to install them, but won't force you. Static code analysis is another thing that we've been using to try and improve the developer experience. So sometimes people miss things. So this is an IDE. It's telling me I've got a problem with my code. And it's not easy to see. Less obvious as well. So because people were missing these things, some of these things as well, we didn't want to put them as an error, because if we did, we'd have to go and clean up like 10,000 things. So we created this little Node.js CLI tool that takes the MRDiff and the linting and compiler output and then comments on the PR. So it'll just help the code reviewer pick up some of these compiler warnings or static code analysis rules getting in. And the other thing we did is the same tool, we were looking into duplicate code detection, and we just changed it slightly to accept some output from JSCPD. So you can add this into your pipeline. We've got GitLab templates for this if you're interested. And it alerts the code reviewer to potential duplicates by commenting on the MR. This we found was really useful because sometimes if someone comes into your code base and they copy and paste a lot of classes, it's not really visible on the MRDiff because the code they copied was code that doesn't come up. It's code that was already in the repo. And whenever I talk about static code analysis and things like this, people always tell me, SonarQube is awesome, we should use it. We actually did use SonarQube a long time at Agoda. But what if I told you you can use SonarQube without using SonarQube? The big advantage to SonarQube is all the static code analysis rules it has, and these are all open source. So if you want to use any of the analysis that SonarQube does, you can just go and install their packages. You don't need to pay an exorbitant amount of money for a SonarQube license. So I'd recommend checking them out. They're really good. Now I don't have Q&A, but if you guys have any questions for me, you're welcome to come up and ask afterwards or just ping me on Slack or anything, and we'll share the slides later. I've got a lot of links in my slide. Thank you.